This problem could be thought of as a denesting problem, I suppose. That's probably not the best instructions to use. But when you want to denest a radical expression, that means just have at most one radical left, meaning you don't want a radical inside a radical. Okay, so that's the meaning of denest. Now we could probably do without that, simplify. Usually people understand these directions, although it can mean a variety of things. Now, notice that if we can somehow or another get this radicand into this form a minus b squared, due to the fact that square rooting and squaring are inverse operations, we get this a minus b here. I guess technically this is the absolute value of a minus b. But in any event, squaring and square rooting are inverse operations. So if we can express this radicand, 48 minus the square root of 1980, in this form a minus b squared, will be home free. So the reason is a minus b squared expands out into this very well-known form right here. Now, so it makes quite a bit of sense to equate the integer portion of this radicand to the sum of the two squared terms. All right, and then 2ab, set that equal to the square root of 1980. Okay. And that makes tremendous sense. We might anticipate irrational solutions here. When you square an irrational number, you can get a rational number. So that's one of the reasons that motivates these two assignments. Okay, so now the first bit of arithmetic we have to do right here is 1980 is equal to the product 4 times 495. And we should anticipate this radicand containing a factor of 4 because the square root of 4 is the 2 that you see in this algebraic identity here. Okay, so again, if you factor out the square root of 4, that would just be 2. And so we end up with this statement here, AB is equal to the square root of 495. Okay, now, so at this point, we're looking for factorizations of 495 such that the two factors will sum up to 48. And we're anticipating irrational factors here. When you square those irrational numbers, you'll get an integer in this case. Okay, so what is this factor to, or what is this? Let's see, what do we get here, folks? Is that 5 times 99? Okay, so this is equal to 5 times 100 is 500, right? So this would be 5 times 99. Now, y'all, that could be broken apart into the square root of 5 times the square root of 99, right? But 99 plus 5 does not add up to 48, and that's what we're looking for. So let's try again. Okay, why don't we steal maybe a 9 from the 5? And so this would also be equal to the square root of 45, right? And I'll split it apart this time, times square root of 11. Right, folks? And what I did there is I took 9 away from 99 and multiplied it against 5 and got this possibility. But notice that 45 plus 11 does not equal to 48, so we got to keep going here. What's another possibility? What if we take 3 away from this? Would that work? Yeah, it looks like it. We're going to get the square root of 15 times the square root of 33, right? And that's looking very nice because when you square the square root of 33, you get 33, and the same with 15. 33 and 15 sum up to the 48 right here, right? So 15. Again, you're looking for the assignments a equal to root 33, right? And b equals to root 15. Okay. So good enough, folks. That got the job done. And again, this thing had to be designed to work out. If you had something here where 4 wasn't a factor, you wouldn't get this necessary 2 to satisfy this identity. But with these assignments, we're going to get this is equal to the square root of 33 minus the square root of 15. So you may say, did we really denest? Well, I think the definition of denesting is just don't have a radical inside a radical. Okay, so this is our answer. All right, back up here, there's our original problem, and we denested it. We simplified it, and notice that this is a believable answer here because 48 is a little bit bigger. I think the square root of 980 is between 40 and 45. Maybe 44 and 45, folks. Okay, I'm not real sure. I think that's right. 45 less than 44, like this. Okay, and so they're pretty close together, right? 48 here, 48 squared is a bigger number than 1980. This is going to be some number probably between 1 and 2, maybe. So it's a fairly close. I mean, they're 48's not a whole lot bigger than this, but in any event, this is the answer, and I hope you enjoyed the process here. This particular identity. There's other types of identities that come up on these type of problems. This one with the conspicuous minus sign seemed to be the one that would probably work if it did work. And there's no assurance this would have worked out. It just happened to work out. All right. Thank you for viewing.